Kia ora, Year 11 and 12. Here are the first two parts of question 3 from last year's algebra exam. So both of them involve quadratics. This first one is an easy way achieved question if you've got a good understanding of what it means for something to be a solution to an equation. So here we're given a quadratic and it's 4x squared, blah, blah, blah. And we don't know what this b number here is, but we know that these two numbers are solutions. So if something's a solution to a quadratic, that means that we can write it as a factor. So x plus a half is one factor. Then when we put x as negative a half, this will be 0. 0 times whatever this is 0. Okay, so we can do the same thing with the other factor. Now there are two ways to go here. We need to make sure we end up with a 4x squared. We can times both sides by the same number and this side won't change because it's 0. So if we multiply both sides by 2, this first term will become 2x plus 1. And if we multiply by 2 again, this term will become 2x minus 5 equals 0. So expanding that gives me 4x squared plus 2x minus 10x minus 5 is 0. 4x squared minus 8x minus 5 equals 0. And b is equal to negative 8. So that's all good if you saw what to do. But what if you just got to this point and you got really, really stuck? So let's see what else we could have done, because there's another way to do this one. So suppose we've got x plus a half times x minus 5 over 2, and we have a complete brain freeze. All we remember how to do is to expand. And when we expand, we're a bit worried because we don't get a 4x squared. We get x squared plus a half x minus 5 over 2x minus 5 over 4 equals 0. And we can clean that up now. And we get x squared minus 2x in here minus 5 over 4 equals 0. But hopefully now we'll see how we can get the 4x squared in. We just times everything by 4. And we get 4x squared minus 8x minus 5 equals 0, giving me again b is equal to negative 8. Okay, so that's the first one done. Now let's look at this one. For what values of m does this quadratic equation have 2 equal roots? Now you might be looking at that 2 equal roots going, oh, I don't remember that one. Well, let's draw a picture. This is the first picture we've always got of a quadratic, and this has got no real roots. So this is where the discriminant b squared minus 4ac is negative. What about here? Well, this one's got 2 roots, but they're not equal. They're quite different. And this is b squared minus 4ac, strictly positive. The one that we're after is the one that we sometimes think of as having one real root. And that one is b squared minus 4ac is equal to 0. Okay, so we can say one real root, or we can say 2 equal roots. It doesn't matter. It comes from a pattern like this. Suppose I had that perfect square. Then the reason we say it's got 2 equal roots is because we can do that. Okay, so looking at this one, we want to get this into the usual form of a quadratic. So 6x squared minus mx plus 3 is equal to 0. And then we need to say for 2 equal roots, we want b squared minus 4ac is equal to 0. A is 6, b is negative m, and c is 3. So b squared minus 4ac is going to be negative m squared minus 4 times 6 times 3. And that gives me m squared minus 72, and we want that equal to 0. So what is m? Well, m squared is equal to 72. M is equal to negative 8.485 or positive 8.485. And I've done that to 3dp. Okay, that's all for now. If you have got trouble remembering all of this quadratic stuff, either use the Walker workbook or the Theta book or Education Perfect, or ask me. All of them have got lots of great practice questions on this material. Thanks for watching.